Alright, in this video I'm just showing you how to solve 10 of my top 10 favorite log questions, or exponent and log questions. The first question, you have some money and you're putting it in and you're getting compounded quarterly, so compound interest. So I need to use this formula here. Y over n to the nt. Good. It says initial investment 480, so that's principal. 1 plus appreciate for 7 years, that'll be T. 17% interest, yeah, as if you're going to get that. So 17% interest, and it's compounded quarterly, so that's 4 times a year. So n is 4 to the n, and for 7 years. Whoops. That's supposed to be an eraser. Okay, so n is 4, and the time is 7 years. And they want to know how much money you have at the end. That's a nice, easy one. So you just plug that in your calculator. Okay, I'll do that. 480, 480 bracket 1 plus 0.17 divide 4 bracket to the 28th. Go. So at the end you should get about 15, 39, and 40, we'll call it 7 cents. Okay, so just plug the numbers in the formula. Here's another one. Amount of particular matter left in a solution is given by this equation, where n is the number of filtering steps. Find the amounts left for n is 0 and n is 5. Oh. So all I have to do is use this formula, 600 times 2 to the negative 0.6 times, if it's 0 to start with, let's do that one. So this is for n equals 0. It'd be 600 times 2 to the, well, anything times 0 is 0, even if it's negative, and 2 to the 0 is 1, so this one would be 600. So you'd be starting with 600. That's n equals 0, no filtering steps. And then for n is equal to 5, it would be 600 times 2 to the negative 0.6 times 5. Okay, so the particulate matter is going to be 600 bracket 2 bracket to the, that'd be, I'll just write it out, negative 0.6 times 5. Go. About 75. That's how much will be left after 5 filters. Okay, next question. Given that log A of 2 is that, log A of 3 is that, find log A of 12. So that's a law, the product law, quotient law kind of thing. So if they say I have log base A of 12, that's the same as log base A of 3 times 4. Oh, and there's a 2 there, so I could really write that as log base A of 3 times 2 times 2. And then this is the product law, and so it'd be log base A of 3 plus log base A of 2 plus log base A of another 2. But log base A of 3 from up here is 0.4771. Plus log base A of 2 from up there is 0.3010. Plus another 0.3010. So you put those on your calculator and add them up. 1.0791. All right, next question. Solve that. These are all base 2, so I can write them as base 2. 8 is 2 cubed is equal to, that one's already a 2, times, this would be 2 to the 2x squared. Now I need to combine these. I need to squish those first in order to drop the 2's, so it'd be 2. If you're multiplying common bases, add their exponents. Okay, now I can drop the 2's. That's a property of logarithmic equality. I guess it's for logs, but this is same base. You can get rid of the bases and just equate the exponents. Okay, so if this base is the same, it follows that that's got to be equal to that. It's a quadratic, so let's put it all over to this side. make it equal to 0, factor it. I'm thinking a plus 3 and a minus 1. Yeah, that's right. So this side will give me x is equal to a half, and this side will give me x is equal to negative 3. And I think if you plug both those answers in, they both check. That's question 4. Question 5. Solve this. I've got t in the exponent, so maybe let me write this a little bit better. It should be like this. It almost doesn't look like an exponent there, but it is. Okay, to solve for an exponent, I'll use log. So log base of e of 0.17 is equal to negative 0.19t. Log base e is the same thing as ln, divided by negative 0.19 is equal to t. And now I'll do that. So ln, where's my ln button? Ln of 0.17 divided by negative, 0.19, go. Alright, so it should come out to, when they say 3 decimal places, so 9.326. That's what t will be equal to. Next question. Ooh, there's a good one. Solve this one. You can do this a number of different ways, but I see 2 lns here. That's the quotient law. I'm going to squish those two together. So I have ln of 5x minus 2 is equal to ln of 6 divided by x minus 3. Now it's a property of logarithmic equality. So if I have a ln of something equals a ln of something, whatever's in here has got to be equal to that. So I can basically drop the logs. To solve this, I'll multiply both sides by x minus 3. On the right side, the x minus 3's cancel. And then I'll FOIL it out. So 5x squared minus 2x minus 15x plus 6 is equal to 6. Bring the 6 over, so it'll be 5x squared minus 17x. Oh, they cancel. Equals 0. Then I can factor an x out. So 5x minus 17 equals 0. So either x equals 0, or x is equal to positive 17 over 5. Now, I think at this point you should check these. So for this, x is equal to 0. If I plug a 0 in there, it'll be 0. 5 times 0 is 0. 0 minus 2 is a negative 2. And you can't take the log of a negative number, so I would cancel the 0 out. The 17/5 I think will work, but the 0 one won't work. Next question. Ooh, another one. Here's 2. Let's squish them together using the product law. So it'd be log base 5 of x plus 6 times x minus 6. I'll maybe put that in square brackets because it's log base 5 of that whole thing is equal to 1. Product law. Now change form, so it'll be 5 to the first is equal to this. I'm just going to FOIL that out in the same step. When you FOIL, it's a difference of squares, so it'll be x squared minus 36. I'll push the 36 to the other sides and add, so that'll be 41 is equal to x squared. Then take the square root, so it'll be the square root of 41. And it will be a positive or negative. That's what you always do when you use the square root principle. But if you put a negative square root of 41, I don't think that one works. And so the answer would just be the positive root of 41. The negative one doesn't work. All right, next. Word questions. Currently 52 million cars, increasing exponentially by that. How many years will it take this country to have 70 million cars? So this is one of those continuously compounding or continuously increasing questions. So I need to use the P of t. To the kt, it's increasing, so k, I'll just keep in my mind that it's got to be positive. So I start with 52 million cars, and I'm ending with 70 million cars, E, and they say 7.3%, so this k will be 0.073 times t. I need to solve for t. Okay, I need to isolate this piece, so I'll divide both sides by 52. e to the 0.073t, and then I'll change form. I could divide those if I want, but I'll just leave it as a fraction. Okay, change form, log base e of 70 over 52 is equal to 0.073t. Now divide both sides by the 0.073t. Okay, so ln of 70 over 52, okay, divided by 0.073, go, 4 point something, 4.0719, and they say round to the nearest year, so it's not going to be quite 70 million after 4 years. It'll just be slightly less than that, but if you want to say about 4 years, you'll have 70 million, that'd be all right. Okay, next question. Ooh, more word ones. Certain radioactive type has a half-life of 1450. Just that information, from that information, I can figure out what K is. So I'll set it up. So it's P of T equals P0 e to the KT. So if I start, say, with 10, half-life is when that goes to half, so that'd be 5, equals e to the K. I don't know what K is, but I know it takes 1450 years. Okay, divide both sides by 10, so you're going to get a half on this side is equal to e to the 1450k. Change it to log form. Log base e of 0.5 is equal to 1450k. Some of you are already putting it right into ln form off the bat, and that's perfectly fine. Okay, so now divide both sides by 1450. So ln of 0.5 divide 1450. Well, that's a small number, and it's negative. Negative 0.000478, etc. Okay, so that's my K value. So if I have K, now then the question says how many years will it be required to decay to 80% of its original amount? Oh, okay, so my formula, P of T equals P0 e to the KT. And they want to know how long, so they're looking for T. I know what K is, and to start with. So I'm decaying to 80%, so I'm going to start with 100%, and I'm decaying to get to 80%. So e to the, my K value is negative 0.000478 times T. Same thing, divide both sides by 100. E to negative 0.000478 T. Change it to log form. I'm going to get smart. Ln 0.8 equals negative 0.00078 T. Divide both sides by that. See what that comes out to. Okay, so I got to go ln of 0.8 divided by that other number, which I still have my calculator. Go. So I'm calling how many years? I'm getting 466.795. Let's round it up. Let's call it 467 years. That's going to be equal to T. I like that question. That's a nice one. All right, last question. Newton's law of cooling states that the body temperature, okay, so here's a formula I've got to use. So I'm not using my P of T equals P0 thing. I'm using that formula. Cup of coffee, after 7 minutes, the temperature is 61.2. What will its temperature be in 20 minutes? Oh, this is the same question we just did. So you have to find K and then use the K. So a cup of coffee is 105. So the 105 is my T1. So T1, I'm just going to use this formula up here. T1 is 105 minus T0 is the initial of the surrounding. So the freezer has a temperature of 0, so that's 0. Okay, so this would be 0 plus, and then e to the minus k, and it says it does that in 7 minutes. So 7 minutes, and it changes the temperature to 61.2. Whew. All right. So 61.2 is equal to the 0 plus and 105 minus, so it's just 105 e to the minus k times 7. Same thing, 61.2 divide 105 equals e to the negative 7k. Change form, so ln of 61.2 over 105 is equal to negative 7k. Divide both sides by negative 7. Let's do that on our calculator. Ln 61.2 divide 105, and then divided by negative 7. So my k value is 0.077116, something like that. Okay, so that's k. And then the question says, what will its temperature be after 20 minutes? Oh, okay. So now I know what the k is. I'm looking for t of t. So t after 20 minutes is going to be equal to T0, that's 0. That's what the temperature of the surrounding starts at. Plus T1 was the 105. Minus 0 is what the whole thing starts at. To the E to the minus K. So my K is negative 0.077116. And my time is 20. Yeah, 20. Okay, let's plug that in the machine. So the zeros sort of don't do anything. So it's 105, and then, whoops, I didn't want to do that. 105 e to the negative 0.0776 times 20. Go. So I'm getting 22.45, 4578. And what's it say? To the nearest degree? So do you call that 22 degrees? Maybe 23 degrees. Depends on how they round. If you get all this other, the work done properly, that's what I would say. I maybe rounded this number a little bit, so maybe this might be a little bit higher, so it might be rounded better to 23. Okay, hopefully that'll help you in looking at those Jeff's top 10 questions.